Okay, now if I have one like number 5, you see how it has a negative in front? Well, I do not like that, so I'm going to just divide all of that by -1. It's like basically I'm taking out a GCF of -1, so that's going to leave me with a -1 x squared minus 31x minus 20. In this case, I could try this algebraically, but I'm going to do Desmos. So I'm going to get that set up as 9x squared plus 31x minus 20. And then I'm going to go and I'm going to look at my x-intercepts. I have an x-intercept of negative 0.556. I also have an x-intercept of 4. So I'll go ahead and write down those x-intercepts of negative 0.556, one of the most beautiful x-intercepts we've ever seen, and then an x-intercept of positive 4. Well, the good news is the x is positive 4 is pretty easy to deal with. If I move the 4 to the other side, that would give me a factor of x minus 4, because to move the 4 over there, I would have to subtract it from both sides, or you could just remember you're always switching signs. Now on this one, that would give me an x plus 0.556. But my problem is I do not want that decimal there at all. Especially that decimal looks like it's probably been rounded. It's probably supposed to be a repeating 5 that's just been rounded to 0.556, but we'll show you how to deal with that. On this now, I look at my leading coefficient, which was 9, and I say, okay, if I'm going to get rid of that, I'm going to multiply by a factor of 9. The factors of 9 are 1, 3, and 9. Well, multiplying by 1 clearly won't do any good. We could go ahead and try multiplying by the negative 0.556. We could multiply that by, let's see, 3. You notice I multiply by 3, I still have a decimal left, so that didn't get the trick done. That's nowhere close to 0. If I multiply by 9, on the other hand, you notice it almost gets rid of the decimal. Now, I've had some students like, Mr. Hass, that's not exactly -5. Or remember, I said we probably had some rounding error here. So if I get really close like that, chances are it's good enough, because that's almost 5, and that 004 is just there because of the rounding error. So what I need to do now is I need to multiply that parenthesis there by 9, because multiplying by 9 seems to get rid of my decimal, and that would give me a 9x and a, let's see, plus 5 would be what I would have there, because multiplying by 9 won't change my sign, and an x minus 4. If you needed to check that to just confirm you were right, you could just multiply your outside terms and your inside terms. So multiplying the inside gives you a 5x, multiplying the outside gives you a minus 36, and minus 36 plus 5 would be equal to -1. I'm sorry, would be equal to -31. Now, speaking of -1, though, remember we factored out a -1 as the first step, so that does need to be included as part of my answer. Sometimes you'll just see a negative, or I prefer to write a -1 in front of the whole thing. So don't forget, if you did take a GCF out as your first step, you do need to include that back in as your answer. That will give you an idea of how to do this. One other thing I want to show you, if you are troubled by that rounding error, is if you think it's rounding error, you notice if I add more 5s, it gets closer and closer to the answer. And in fact, the truth is, if I were to, another thing I can do is if I think that's a repeating 5, I can just do that, and then I can tell it to convert to a fraction. So I can go up there, and I should have an option to convert to a fraction, but it's not wanting to work right now. But sometimes you get a little fraction button, and it will allow you to convert to a fraction. There it is. And that will convert it to a fraction for you. I don't know why it wasn't showing up earlier. So if I have a repeating 5, it will convert it to a fraction as well.